obscured by the brilliance of their neighboring stars. But the planets have a minute gravitational pull on those stars. Measure these tiny movements, and we can prove they exist. That's how we tracked down Bellerophon in the 1990s. And hundreds of other distant planets. "65 light years from Earth. Turn on your TV here and you'd pick up Hitler's Berlin Olympics." Twin stars of Algol, known to the ancients as the Demon Star. From Earth it appears to blink as one star passes across the other. Up close it's even stranger. One star is being sucked towards the other. Almost 100 light years from home, faint whispers from one of the first ever radio broadcasts.
We appreciate it if anyone hearing this broadcast would communicate with us. We are very anxious to know how far the broadcast is reaching.
From here on out, it's as if the Earth never existed. Feels like a lifetime since we stood on that beach, looking up at the sky, wondering where and how we fit in. We learned one thing for sure. The universe is too bizarre, too startling, for us to guess what lies ahead. Deep inside our galaxy, the Milky Way. Pinpricks of light that have inspired 1,001 tales. The Seven Sisters, the daughters of the ancient Greek god Atlas, transformed into stars to comfort their father as he held the heavens on his shoulders. And this giant, Betelgeuse, the brightest, biggest star we've seen so far, 600 times wider than our sun. But this, it's not a star, not a planet. Not like anything we've seen. A ghostly specter more than 1,300 light years from Earth. Orion's dark cloud. Dust and gas shrouding us. There, deep inside, a light, pulling the dust and gas towards it, heating up, merging into a ball of burning hot gas. Like a star, like our sun, in miniature. Inside, it's millions of degrees. So hot it's beginning to trigger nuclear reactions, the kind that keep our sun shining, making energy, radiation, light. A star is being born. Orion's dark cloud is a vast star factory. We're witnessing the birth of the future universe. We've come to expect destruction, but this is one of the universe's greatest acts of creation: star birth. This doesn't look right. Jets of gas exploding out with tremendous force, blasting dust and gas out for millions of miles. It's unbelievably violent and creative. Nebula. Vast, glowing clouds of gas hanging in space. With no wind out here, they'll take thousands of years to disperse. They seem to be forming a vast stellar sculpture. Nature is more than a scientist, an engineer. It's an artist on the grandest of scales. And this is a masterpiece. Stars are born, grow up, and then what? Do they die? Do they slip quietly into the night or go out with a bang? Somewhere between here and the edge of the universe lies the answer. Luminous clouds suspended in space, encircling what was once a star like our own sun. All that's left of it are these brightly colored gases, elements formed by nuclear reactions deep inside, released into space on its death. Green and violet, hydrogen and helium, the raw materials of the universe. Red and blue, nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. Every atom in our body was produced by nuclear fusion. In stars that died long before the Earth was even born. We are all the stuff of stars. Our family tree begins here. At its heart, the ghost of a star. A white dwarf. White, hot, small, but unbelievably dense. In the star's dying moments, its atoms fused and squeezed together, making it so dense that just a teaspoon of this white dwarf would weigh 1 ton. It's a chilling premonition of our sun's fate. 6 billion years from now, it'll become a white dwarf. Its death will herald the end of life on Earth. Makes you wonder how many other worlds have come and gone. Celestial stories left untold. Lost forever. But the greatest story of them all is still to be told. We must go back